because we have a Z record for every single sample, we can actually create a point cloud out of this image, which is pretty cool. Since maybe when you first load an image, a deep image, you don't really know where it sits in the scene in 3D. You can use this tool here, the Deep to Points, to create a 3D scene and get a sense of where the pixel is in depth. You need the camera, the original camera that was used to shoot the scene. It is actually recorded. The position is recorded in a matrix in the EXR files, but you'll have to get it into Nuke's coordinate system. So we just copied this out of Maya to get it. That's the quickest way to get it. And as you can see, it very quickly will produce a point cloud of the guys. This is even subsampled right now. It's dropping out, it's only taking 1/4 of the actual samples to build this. But if you wanted to increase the resolution all the way up, you can create a very dense point cloud and get a very good sense of where stuff is in the scene. Because when we did the deep merge here with the combine, we did not have it drop the hidden samples. It means that it actually continued to store all of the deep stuff in those back sample buffers of the stuff behind our big robots. Our little robot is still back here, and all of the ground and everything behind our guys. If we drop hidden samples, though, it will cut those out. And once this has a chance to refresh, you'll see that it is dropped out. It's attempted to drop a lot of the samples that are occluded behind there. So, if you find that if you're stacking up a lot of deep stuff and your end target is to produce a 2D image, you might want to, in each one of these deep merges, make sure that you drop hidden samples, and it will cull those samples that you're not going to be looking at downstream, and kind of lighten up the buffers as you go down. So it really just depends on how you're going to be using it, but that's just something to be aware of. You might want to keep them because then it gives you a little more flexibility in how you're working if you still have the samples. But it's already heavy enough as it is, deep compositing, so this could be an optimization you could use to sort of clean things up a little bit as you go and speed up your workflow. I'm going to leave them in for now just so that we can see this point cloud, which is pretty cool. Okay, so what are some other things you can do? Let's get this off to the side here and disable it. You can't manipulate these like regular images when they're in a deep mode, when you bring them in as a deep file from the very get-go. So in order to manipulate them, you'll have to use the tools provided in the deep tools here. And there's a few color corrections. You have deep recolor and deep color correct. So if you need to do some basic color corrections, let's say I wanted my big robot to be color corrected, I could just drop in a deep color correct, and it's very similar to the normal color correct. So it's not quite like a grade, but it's got a lot of the same controls and more. You've got saturation and stuff. So let's say I wanted my big robot to be totally desaturated and a little bit brighter. Make him look like he's a different kind of metal, or I could even tint him here. So you can get a lot out of a color correct. So this is you might not need another color correction because this will do everything that most of the other color corrects will do. Plus, it has a saturation slider, which most of the others don't have. So just remember that you'll have to set the ranges like you would normally in a color correct node. So here's a way, without changing it out of deep mode, that you can do color corrections. Let me just show you how. I'm going to try to attach a grade to this, and you can see a traditional grade or a traditional 2D color correction will not drop in here. But you can promote these if you can't find a tool to do your color correction or the manipulation that you want to do here. Since you've only got a couple choices, you can promote it to a traditional image using Deep to Image here. The one caveat is that you'll have to go, of course, image to deep when you're done. And any manipulations that you do on here, you'll have to make sure that you don't edit. So I'm going to drop down a grade. You have to make sure that you only edit the RGB and maybe alpha if that's what you intend to do, but that you only edit the color channels and not inadvertently edit all, because the deep samples are still being passed through here. If you were to change, let's say, your deep files, I'm going to just only change the deep here. So let's say that I multiplied them. You'll see it'll move them, it'll move the guy around. And mess everything up. So this is the street. So I'm sort of moving the street forward by changing the deep buffers. So, well, this is just depth. So just something to be aware of. Don't edit the depth, the deep buffers while they're coming through here. Another caveat to be mindful of is that some 2D manipulations might not make any sense to do upstream in a deep composite. Like, for example, if you wanted to do a deep focus here, this would probably be a very dangerous place to do a pixel filter where you're actually blurring things, because you'll break the relationship between the deep buffers and the actual RGBA pixels. So let's do an example of that. I will put down just a simple blur here. Now, this might not be the best stack to do it on. We'll do this on our big robot here. So I'm just gonna copy all that stuff out and bring it over to the big robot. And we'll put in just a blur filter here. And we're perfectly capable of doing a blur, but as we do this blur, you'll see we're screwing up even if we don't screw up the deep buffers, we only do the RGB or RGBA, because we can't blur the deep buffers in a meaningful sort of way, we're going to get an artifact on our thing. So this is when you might have to start thinking about, well, this isn't a valid use case. You should never need to do this particular thing, but just keep that in mind. A pixel filter is not really going to maybe have the desired result if you do it to a deep image. Maybe the one thing that would be a valid use case would be to try to do defocus, and I'll show you how to do that in a second. But yeah, don't try to do pixel filters in isolation here, because it's think you could almost think of this as like the pre-multiplication of Z state. Like you have to basically maintain a valid Z relationship, Z sample relationship between the RGB samples, as you would keep the relationship between the alpha channel and the RGB in a pre-multiplied versus unpremultiplied state. So until you've done the composite, you're not really free to do pixel-wise filters, because you can't filter the Z the same way. So let's do some defocus on all this. So what's a recipe you can do to do defocus? Well, you can stack them all up like this, and then drop your Z defocus down here at the bottom. And as in most cases, this will work. Now you'll have to promote this back to an image though. So I'm going to go deep to image. Now I have an image. I can attach my Z defocus to that because it's now an image. And you could use the depth, but you actually have a slightly better depth in the deep front in most cases here. So you might want to use the deep front and use the depth math here. And we'll make sure that we pick a cool focal point like here. There you go. And so, you know, doing defocus on a CG thing when you've got deep compositing, it's a cakewalk. It's super simple. So that's how you would do it. That's how I would do it. I would defer the Z defocus until the last. Typically, this wouldn't always work so well, because compositing the Z buffers, you might almost have to have a separate track for that. If you do notice that you're getting slight artifacts in here along this edge, because it is still using an unanti-aliased Z buffer here, you could either adjust your focus point to maybe blur out that edge a little, or you could actually blur that channel a little bit instead. So, that's another option you could do. Try blurring your focus. Part of the reason you can't use the Z is it won't always be normalized the same. It looks like it's working here, so you could use the Z buffer as well. Looks like the math is actually working a little bit better, though it's working a little worse in some places. So it really just depends on what you're trying to do. They're normalized a little differently, so that's just something to keep in mind. The depth is in a scene depth sort of mode. It's bigger numbers, so. But either one will work, just as long as you're not recognizing any artifacts in there. Okay, so what if you have to mix and match deep renders and not deep renders? Well, let me disable this here. There's another set of tools that will allow you to do holdouts, so you could do a deep holdout here. So if I was to take, let's say, I had this problem where these things were sandwiched. I needed to hold out my big robot from my small robots here. I could use a deep holdout, and that would knock the big robot out, and now I could do traditional pixel compositing here. So let's build a scenario where we have to do that. So I have the holdout, and we can't just use traditional pixel logic here. We still have to go and turn deep to image, right? So I'm going to turn them both, my held out version, deep to image. Oh, I guess this already promoted it to an image, so that's great. So now I have an image, but I have to turn my original one here into an image. So I have two images. And how do you combine something like this with something like this, with a holdout that already has the alpha channel built in? It's really quite simple. You just add the two together. If you try to do a traditional over merge, I'll show you what happens. So we're going to just do an over here instead. And you see this little crack that appears? That's because it's pre-multiplying that edge again. So you'll get those kind of artifacts. There's another tool in Nuke called a disjointed over, which has a little bit of a conditional that will keep that from happening. So you can use this as well, disjoint over, or if you want to be perfectly mathematically accurate about it, just add the two together. And if everything's working right here, we shouldn't have our alpha channel go over 1. Yep, because all that math was correct. We do have it going over 1 here. Did our holdout? Oh, that's because we didn't hold this out from that. So we'll have to make sure our order is correct if we do our disjointed over, or we'll have to hold the other one out from the other. So in this situation, the disjoint over would be the correct thing, and we would make sure that this went over that. So that would be the correct logic to use here. But if they were mutually held out, then you could just add it over. You'd have to hold this out of that, but there's no point in this case because it's already been prepared properly to do a disjointed over. So now that you have that, you can just do a traditional over the background, right? So we have our we could turn our background to regular pixels and just do a regular merge over. Now there is one moment where this guy kicks the cone here, but he might always be over it, so it may not matter. Yep, he's always over the cone, so this would work. So that's how you can convert these back into traditional pixels and do you're compositing in pixel land. I would, as long as you've got deep files, I wouldn't bother. I would just composite them as deep files, do all my math or all my comps in there, put a little bit of defocus on there. And now since we're already pixels here, you can just put a regular write node down and write them out as regular pixels.